Hello everyone, in this video I'll introduce you to the stepper drivers world. I'll show you what stepper drivers are, what they are built from, what makes them work, how to set them up, and finally how to choose the correct one for your motor. First things first, what stepper motor drivers are. They are used to obviously drive a stepper motor. Since it's no ordinary motor, it needs a special driver. You can learn more about stepper motors in this video. Stepper motor drivers are driven by at least two signals from the main controller. These signals are called direction and step. As their name suggests, the direction signal is responsible for choosing the direction of the motor, and the step signal is responsible for moving a motor by a single step. There is sometimes a third signal called enable, which can be used to enable or disable the driver, but for basic configuration it's not needed. Let's see what's inside the driver. Its cover is usually held by two screws. Once you undo them, you can leave the cover. There's a lot going on inside, so let's start with the beginning, the power supply. This depends on the model, but usually on the input we can see the full bridge rectifier. It's used to convert AC voltage to DC voltage. Then the voltage is smoothed using a big capacitor. This smoothed voltage is used to drive the motor and to power the control electronics. Speaking of which, we have a microcontroller responsible for handling the inputs as well as outputs. For inputs we have previously mentioned direction, step and enable signals, and also the dip switch for settings of the driver, which I will explain later. Every input is galvanically isolated using an opto-isolator, which basically consists of an optotransistor and an LED. Finally, we have 8 power MOSFETs in dual H bridge configuration. This means with this setup we can drive 2 motor coils in both ways. MOSFETs are attached to a big heatsink on the back of the driver because they can get very hot with big loads. As we now know the basics about the stepper drivers, we should learn how to use them. As I have mentioned before, we need at least 2 signals from the main controller to make our drive move. These signals are step and direction. Both of these signals are square signals. For example, when the direction signal is a logic 0, so near the 0 volts level, the motor moves in one direction, and when the direction signal is a logic 1, so near 5 volts, the motor moves in a different direction. When it comes to a step signal, it's very simple. Once the step signal is a logic 1, the drive performs one step. It will not move another step when the signal is always a logic 1. It needs to be square wave signal. That's pretty much it when it comes to controlling the stepper driver. Let's get to configuring the driver so our system works as intended. On the driver's cover we can usually find a huge spreadsheet of settings. These are guides on how to change the interpolation and motor current and sometimes other settings. What is the interpolation, you might ask? It's simply how much pulses or steps the motor has to do to perform one rotation. The more you have, the more precise your machine will be. Can you set it to max? Not really. It has to correlate with the mechanics you've used, and your main controller must be able to provide the huge amount of signals in a timely manner. I will explain more why you can set the maximum interpolation in a different video. So how do you use the settings spreadsheet? On the stepper motor driver there's something called a dip switch. It's usually a blue array of small levers. To set the interpolation of the drive, you look at the spreadsheet and read the top row of the table called pulse per revolution or something similar. In this case it's switch 5 to switch 8. For example, let's set the interpolation to 3200. We have to find in the column on the left and see what switches need what state. On this drive it's on, off, on, and we have to replicate that on the dip switch. So switch 5 has to be on, switch 6 also on, switch 7 has to be off, and switch 8 has to be on. This sets the interpolation of the drive to 3200. The same procedure is for all other interpolation settings. Now let's change the motor current. You must not exceed the motor current rating as it might lead to damaging it. For this example, I will set the motor peak current to 3.2 amps. It's pretty much the same thing as we did with the interpolation, so on this drive for 3.2 amps it's on, off. Now we have to change the switches 1, 2 and 3 to these states. And that's it when it comes to configuring the drive for a motor and a control system. Last but not least, let's learn how to pick the correct drive for a motor. The main parameter you need to know is the current your motor works at. You will have to choose the drive which is capable of providing such currents. For example, when your motor current is 3 amps, you will have to choose the drive which has at least 3 amps RMS on its output. When it comes to voltage, you just need to stay within the driver's input range, but keep in mind that higher voltage gives the motor better torque at higher speeds. Lower voltage will still work, but the motor might feel noticeably weaker, especially when accelerating. However, from my experience, it's better to stay within the maximum range of the driver's voltage. For example, when the driver's voltage range is 30 to 110 volts DC, it's better to keep the voltage from 70 to 110 volts DC. At lower voltage, the motor might get significantly weaker. In conclusion, now you know what stepper motor drivers are, how they're built, how to use them and how to configure them. For now, that's it for this video. Thank you for watching and I will see you in the next one.